Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about the different trig functions, sine, cosine, and tangent. Okay, and we have a acronym to help us remember that. It's called Sohcahtoa, right? Sohcahtoa, and we say it real quickly as Sohcahtoa. Okay, now the first thing I want to make very clear before we start actually looking at problems and solving is that your calculator must be in degree mode. Okay, I cannot say it more plain than if you do not take the step to put your calculator in degree mode, your answers will be wrong. And it's that simple. You can put everything in exactly right and your answer will be 100% wrong. So this is just something that you have got to remember. So let me show you how to put your calculator in degree mode. Okay, so bring out your TI-84 or equivalent. Okay, you want to cut it on, of course. And we are going to hit mode right here, MOD, right beside the second button. So we hit mode, and right down here we're going to go down to the third option, and you'll notice radian is highlighted. That's the standard, what your calculator is on. After you clear it, it'll be on radian. Okay, we want to move it over one and hit enter. It must be on degree mode. Now from here, you can hit second mode to clear and go back to your home screen. Okay, and so now your calculator is in degree mode. So if I were to clear my calculator for any reason, it would go back to radian and I would need to manually go back in and change it to mode again. So that's probably the number one place where people go wrong on this section, is they forget that. Okay, so now that we've got that established and taken care of, it'll be ready for me when I need it. So Sohcahtoa. We use Sohcahtoa when we're given one. We use it with triangles, okay, right triangles specifically. And when given one side, one angle, and we're looking for another side, that's when we use Sohcahtoa. So again, it's got to be a right triangle, okay, and you have to be given a side and given at least one side and at least one angle. Okay, it's important to note that some people want to try to use Pythagorean theorem here. That's when we're given two sides and we just want to know the third side. Okay, so big difference there. So for this one, when given one side, one angle, and we need to know another side. So some important terminology here. You're going to hear these words a lot. We need to know the placement of them. We've got hypotenuse. Now, hopefully you're pretty familiar with that word by now, but if you're not, a hypotenuse on a right triangle is the side directly across from the right triangle. So where you see this little box in the corner, okay, that shows me that's the 90-degree angle. When you look directly across from there, that is the hypotenuse. Okay, and then we'll get into opposite and adjacent and placing those things. This little symbol right here is a theta symbol, and at this point, it's just kind of like a placeholder, okay? So I'm showing, this is where I would be standing, okay? This is my given angle. Right now, there's not a given angle in there. It's just a placeholder, okay? So let's come over here, and then we'll come back. We have three different trig functions. We have sine. Now that is not, I know it looks like sin. It's not pronounced sin, it's sine. So sine, cosine, and tangent. Okay. Now sine is opposite divided by the hypotenuse. So that's where the so comes in for Sohcahtoa. So you notice each, the first letter of each part is contained here. So sine is opposite over hypotenuse. Okay, so that the so helps us remember that. Cosine is adjacent over hypotenuse. So when we come over here to the cosine is adjacent over hypotenuse. Tan is opposite over adjacent. So here we go. Tan is opposite over adjacent. Okay, so Sohcahtoa is just a helpful way for us to remember. That's all it is, okay? So we will only use one trig function at a time. Now, sometimes in problems, we'll use more than one in the same problem, but we are only going to use one at a time, and we'll see how those work. Now, a couple little terminology things we need to clear up. So we talked about what a hypotenuse is, and we saw that pop up twice in here. But what about opposite and adjacent? What do those mean? Well, let's say that this is the angle that we're given, right? This angle right here. So right now I told you we've got a placeholder just with the theta symbol, right? But let's pretend that that was a degree there. They told us what that angle was. The opposite degree would be if I'm standing here and I look straight across. Okay, and sometimes I think when you're learning this, it helps to actually draw an arrow. You're standing here and we look straight across. Whatever is there, that is your opposite. Okay, now are we always going to be standing here? No. Sometimes you'll be standing up here, right? And that would make this your opposite. Okay, so that's where it gets a little tricky, but don't just look, where am I standing? Look straight across, okay? We talked about hypotenuse, that is the one straight across from the right angle. So sometimes I think it helps to label those two first, and then whatever side is left, okay, it's the one that touches the angle, but is not the hypotenuse. But whatever's left, that's your adjacent. So while you're still learning this, I think the best thing to do is label the opposite, label the hypotenuse, whatever's left, that's your adjacent. Okay, so for every problem, your placement may look different, okay? But depending on what they've given us and what we're looking for, that will determine which of these we use. Okay, so let's see some examples. Let's look at this first one right here. So I've been given triangle A, B, C. Okay, I see it is a right triangle. That's a must. I cannot use Sohcahtoa unless it is a right triangle. And they've given me this angle. They've said this is 30 degrees, this angle right here. Okay, angle C. They've given me let's look, if we're standing here and we look straight across, this would be the opposite, right? So I can label it, and I usually will just label it OPP, opposite. They want to know, they've labeled right here X, they want to know, what is this one? Well, I see it's directly opposite the right angle, so that would make it the hypotenuse, and I can label it HYP. So that would make the adjacent down here. Now notice they didn't give me anything for the adjacent, and they're not wanting me to find the adjacent, they just want to know the hypotenuse, so that does not help me at all, okay? So what that tells me is I need to look at what I'm given. So I've been given an angle, I have been given the opposite, I want to know the hypotenuse. So I come over here now, and I say which of these trig functions uses opposite and hypotenuse, okay? And hopefully you're looking right here and saying, well, this one does, sine equals opposite over hypotenuse, right? Not here, this one uses adjacent. Not here, this one uses adjacent, okay? We're going to use sine. That is going to be our trig function for this problem. So the way we set this up, this is so important, is we say sine of what degree? Well, we said we were standing here, right? So that was 30 degrees. So we're going to say sine of 30 degrees equals, and here's where our formula comes in, opposite over hypotenuse. So opposite was 37 over divided by the hypotenuse, which was X. That's what we're looking for. We want to know X. Okay, now I treat this, it looks way more complicated than it really is. I'm going to treat this just like an algebra problem. Okay, anytime I have something divided by a variable, and I want to get rid of this fraction, remember that I can multiply by the denominator. Remember doing this? Multiply by the denominator. And when I do that, it cancels the denominators out. But I can't just do that to one side. If I'm going to do that here, I've got to do it here as well. So I got to take sine of 30 and multiply it by x too. Okay, so let me bring down what I have. I have x times sine of 30 degrees, right, equals, I canceled the denominator here, so I just have 37. All right, now I want to get x alone. So this is x times sine of 30. So what's the opposite of times? Divide. So I can divide by, now I know this feels weird, but I promise it's going to make sense. I'm going to divide by sine of 30, whatever I want to cancel by, right? So when I have something divided by itself, remember it cancels. But what I do to one side, I have to do to the other. So if I'm going to divide by sine of 30 here, I've got to do it here. Okay, so at this point I just have x alone, which is exactly what I wanted, equals, what is 37 divided by sine of 30? Well, this is where our calculator comes in. Okay, so we're going to bring that over, and we're going to type it in exactly as it's written. 37 divided by sine of 30. Okay, so you'll put the degree in those little parentheses. Okay, now, probably another huge student error I see is they want to say sine of 30 divided by 37, but we know it doesn't work that way, right? You always divide top to bottom. Okay, so if 37's up top, that's what you put first. All right. Let's see what our answer is. I get 74. So now I know what x is. X is 74. If I wanted to come and label it over here, I could. X is 74. Okay? So we're going to use the same kind of setting up format each time, depending on which one we're using. So for this one, I'm standing here. Look, this is the angle they gave me, 45 degrees. Okay? I see that the opposite would be down here, right? This would be the opposite. And I could label it opposite, but look, I don't know what the opposite is. They're not asking me what the opposite is, so that really doesn't help me. I want to look at what have they given me and what do they want to know. So I see that they've given me, look, this would be our hypotenuse, right? Because it's opposite the right triangle, the 90 degrees. So I'm going to label that hypotenuse, HYP. And we said this was the opposite down here. So what does that leave this over here? Well, it's got to be the adjacent. And I label it A, D, J, adjacent. So which of my trig functions uses a hypotenuse and adjacent? Let's see, and it doesn't have to be, in that order, just which one uses the two. Not sine, cosine, adjacent over hypotenuse. Okay, so let's set this up, only this time instead of writing sine, I'm going to write cosine. So I've got cosine of what degree? 45 degrees. And it equals adjacent over hypotenuse. So we said the adjacent was x over the hypotenuse, which is 24. Okay, so I've set up my trig function. Let me use my algebra rules to solve. Remember, anytime we've got a fraction that I want to break up, right? I don't like dealing with fractions. I multiply by the denominator, in this case 24. That cancels, makes it go away. But if I do that to one side, you have to do it to the other. Okay, so let's simplify this. I've got x alone over here now. It was just in the numerator, so it's just coming down. And then I've got 24 times the cosine of 45. Well, I can put that in my calculator and simplify it. All right, remember, we're on degree mode. So 24 times cosine of 45. Cosine, and I don't know if I pointed that out. I kind of breezed through it on this one, but these are our trig function buttons right here. Sine, cosine, and tangent. Very handy, okay? So notice I just hit cosine this time instead of sine. So cosine of 45 degrees. We don't need to put degrees in. It understands that that's what we're saying. And let's see, 16.97 and then a bunch more. Okay, let's round, and I'm just going to say let's round to, let's just go 2 decimal places, 10 hundredths place. Okay, so I'm going to say 16.97. So x equals 16.97. All right, so that is my answer. That's what x is. In this case, my adjacent, it is 16.97. Let's do one more example together. So in this one, I want to look, okay, where's my angle? I've got a right triangle. I've been given one side, given an angle, wanting to know another side. So Sohcahtoa, definitely what I want to use. So I'm standing here. This is the angle that they've given me, 12 degrees. Okay. I want to look at what else have they given me and what do they want to know. Okay, and let's label those parts. So if I'm standing here and I'm looking straight across, what do I hit? Well, 15, and that makes this the opposite. Right? Now I know here's my right triangle, here's my right angle, right? And if I looked straight across, that would make this a hypotenuse. Now, they didn't give me a hypotenuse, and they don't want to know what it is, so that does not help me. I could label it hypotenuse, but that really doesn't help me. So what does that make this? Well, if this is the opposite, and this is a hypotenuse, this has to be the adjacent. So which one of my trig functions uses opposite and adjacent? And hopefully you're seeing the one we haven't used yet, right? Tan. Okay, tan is opposite over adjacent. So let's set this up the same way we did those. Tan of what degree? 12 degrees. These you just have to practice setting them up in this format. Equals opposite 15 over adjacent x. So this one's going to be very similar to the first one. Notice because our x is in the bottom, okay? So it's going to work out very similar to that top one. Anytime I have a fraction I want to get rid of, I can just multiply by the denominator, in this case x, right? And those cancel out. But if I'm going to do that to one side, I have to be fair, I have to do it to the other. So at this point, I've got x times tan of 12 degrees equals 15. Just the numerators left. Now I want to get x alone. So this is x times tan of 12 degrees. So let's divide by what I want to get rid of, tan of 12 degrees. Now these, hopefully you recognize, cancel, right? Anytime we divide something by itself, it cancels to 1. And if I do that to one side, I gotta be fair and do it to the other. Okay, so at this point I've got x is alone now, equals 15 divided by tan of 12. This is when I've got to bring my calculator in. So we're going to put it in top to bottom. 15 divided by tan of 12. Tan of 12 degrees equals 70. Let's just do the nearest, hundredth again. So 2 decimal places. 70.5. That 6 would round to a 7 because that's a 9. 9 is greater than 5. So 70.57. That would be, if this is 15, that would be 70.57. So for this one, notice it says, and I'm going to tell you, these are the easiest questions on your quiz, your test, your final exam, whatever it is you're taking. These are the easiest questions, okay? Because all you have to do, they're saying sine of 3.5 equals what, okay? Look at how easy this is. I just go to my calculator and I put in sine, making sure I know I'm in degree mode because I haven't cleared my calculator. You make sure you're still in degree mode, okay? And I put 3.5, so sine of 3.5, close out your little parenthesis, is 0.06, and we'll just say 0.06. We'll just go to the nearest hundredth. So my answer is 0.06. Okay, let's do, it's that simple, okay? Let's do cosine of 75. So all I do is I go to my calculator and I type in cosine of 75. Close your parenthesis out. And I get 0.2, we'll round that to 0.26, okay? 0.26. Now the last one, they're asking me for tan of 55. So let's see. Tan, I hit the tan button of 55. And I get 1.43. We'll round it. 1.43. Okay? That's it. That's all you have to do on those. So don't freak out when you see those. Those are the easy answers. Now I'm going to let you guys try one on your own. So notice how they've given you an angle, they've given you a side, and they want to know another side, okay? It is a right triangle, so this is a perfect candidate for Sohcahtoa, okay? So you've got to think, all right, what have they given me? What do I want to know? And that will tell you which trig function to use. So I will post the answer in the video description below. This has been Miss Math Tutorials.